Okay, maps and scale drawings. You're familiar with maps. You've seen them, but you've probably taken for granted that they're drawn accurately. And the reason they're drawn accurately is because somebody studied math and they knew that they had to have their proportions correct in order to make the map useful. Okay, because if a map is not drawn to proportion, then the map won't be able to be trusted. So proportions do come in handy, and this is one of the ways that they do. Now on this map down here in the middle bottom part, you've got it tells you that this distance right here, this distance right here is 20 miles on the map. Okay, and it also tells you that this distance is 35 kilometers if you intend to use kilometers. So if you were to measure from here to the border of Panama, okay, from San Jose to the border of Panama, and then you divided it by this distance right here and found out how many times that repeated itself, you could estimate how far it was from the border of Panama to San Jose. This map is a little bit different. It has a legend that goes with it. Now, a legend is something that tells you what little icons represent. This icon represents national parks and reserves. This is the Pan American Highway. The star represents the capital city of San Jose right here. And then down at the bottom, it has a scale. And on this map, it's 50 kilometers is this distance on the map. Now, what that tells you is this map is drawn to a smaller, well, it's drawn more compactly than the other map is. So that distance on this map is further than it was on the other map. They also use scale drawings for architecture. Before somebody actually built your house, somebody drew it and drew it to scale, and they miniaturized it and made it so that an architect could look, that a builder could look at it and be able to build the house from the drawing that was given to them. And on it, they also have scales. They'll tell you how many feet a certain distance is, because whenever somebody looks at this, they have to be able to trust the dimensions of each little piece that they're drawing here. Alright, the length of the side of this house, okay, when somebody measured it on the scale drawing, is 3 centimeters. So from here to here, somebody measured it and it was 3 centimeters. What is the actual length of the house? Well, down here it says that 1 centimeter is equal to 2.5 meters. So we write 1 centimeter is equal to 2.5 meters. It says the length of the side of the house on the scale drawing is 3 centimeters. See, I put centimeters on top here, so I've got to put the 3 centimeters on top also. And then the actual length goes on the bottom. And then it's just a simple proportion that you're comfortable doing. 1 times x gives you x. 3 times 2.5 gives you 7.5. So the actual length of the side of the house is 7.5 meters. Alright, your turn. The length of the chimney on this house, somebody measured it on the scale drawing and it came out to 4 centimeters. What is the actual length of the chimney? You pause the video, take your turn at it, and see what you get. Okay, so just like the first one, we write down 1 centimeter is equal to 2.5 meters. So we write that down. And on the other side, we write 4 centimeters over x. You want to keep centimeters with centimeters and meters with meters. And then we do our cross multiplication. 1 times x is x. 2.5 times 4 gives you 10. So the length of the chimney is 10 meters. Okay, some definitions here. Scale drawing is an enlarged or reduced. Well, when you think about a map, you think about it being reduced because you think talking about a continent or a country, okay? But they can actually be enlarged because you could be talking about a microchip, okay? And the microchip is very small and somebody wants to see what it would look like larger, so it could be an enlarged drawing, okay? But anyway, a scale drawing is an enlarged or reduced drawing of an object that is similar to the actual object. Okay? So, scale drawing, scale drawing, scale drawing. Alright? Now, scale is the ratio that compares a length on the drawing or model to the corresponding length in the actual object. So where's the scale? The scale is down here at the bottom there. And then also the scale is down here. And then I pass this one, the scale is down here at the bottom right hand corner. Okay, the scale of a map is 1 inch to 5 miles. Okay, we've been given a scale of 1 inch to 5 miles, and they want you to find that a road that is 3 inches long on the map, find the actual length of the road. So, we write down our scale of 1 inch to 5 miles. Inches, miles. I'll go one thing further with you, because sometimes this can get confusing. So, the scale of the map, okay, the map I put on top, and the actual I put on bottom. Okay, so now the map is in inches, so it's 1 inch to 5 miles equals, find the actual length of the road. Okay, actual length is what we're looking for, and it tells you that the road is 3 inches long on the map. Okay, so we go 3 times 5 gives you 15. And 1 times x gives us x. So the road is actually 15 miles long. Okay? Now it's your turn. A lake is 35 miles long. Find the length of the lake on the map. Okay? This is actually the opposite of what you just did. Okay? So it's very important that you use this to make sure you do it correctly. I'll let you see how you do. Pause the video. Alright, let's see. So we got map and actual. Once again, the scale is 1 to 5, map to actual. Alright, the lake is 35 miles long actually. So that would go on the bottom. Okay, and the x goes on top. So we go 5 times x. I hope you set it up that way. And 1 times 35. Then we divide both sides by 5. And that gives us x equals 7. So on the map, this lake would be 7 inches long. Okay, a certain car is about 100 inches long and 60 inches wide. I hope that you're getting to the point now where you will draw models of the things that you're working on when you're working word problems. Because the ability to draw a beautiful car like this is something that can be marveled at. So we've got a car that is 100 inches long and 60 inches wide, okay? And we're going to draw a scale model of it that is 9 inches wide. And we want to know how long is it going to be. Look at that, we've got a scale already, I mean a proportion. So we go 100 over x is equal to 60 over 9. 100 times 9 is 900. 60 times x is 60x. Then we divide by 60 on both sides, and that gives us 15 equals x. So x is equal to 15 inches. Very good. Alright, at the right is a model of a boxcar. Okay, so we've got maps, we've got scale drawings, and now we're dealing with a model. At the right is a model of a boxcar. The actual length of the boxcar is 609 inches. So in real life, it's 609 inches long. What is the scale of the model? Okay, so when we're talking about scales, we say we want it to be 1 inch is equal to. Right now we know 7 inches are equal to what? 609 inches. This 7 inches represents 609 inches. So we write that down. Now, how do we get the inches to be 1? It's the same thing when you were doing unit rates, okay? When you were doing unit rates, the thing that you wanted to become 1, you divided it by itself. So which one are we going to divide by itself? Right, the 7. So we divide both of them by 7. If we divide the top by 7, we're going to divide the bottom by 7. So 7 divided by 7 gives you 1, and 609 divided by 7 gives you 87. Okay, but we don't typically write it this way, even though it's okay to write a ratio this way. For maps, we typically write it like this. Oh, if I can hit the button. There we go. 1 to 87. So that's how we would write our scale. All right, your turn. The length of a room in an architectural drawing is 10 inches. The actual length of the room is 160 inches. What is the scale of the drawing? Your turn. Pause the video. Okay, so it was 10 inches to 160 inches. So we write down 10 inches to 160. We want the 10 to become a 1. So what do we divide the 10 by? Yes, we divide it by 10. If we divide the top by 10, we got to divide the bottom by 10 also. So 10 divided by 10 is 1. 160 divided by 10 is 16. So our ratio is 1 to 16. Our scale is 1 to 16. All right, find the actual distance represented by 1 inch to write the scale of a map. What's so different about it? Oh, we have fractions. But don't worry, fractions are our friends, not our enemies, okay? You do the same thing that you've been doing the whole time. We want this 1 inch, 1/4 of an inch to be 1 inch. So what do we divide 1/4 by to make it a 1? Same thing you've been doing with the previous ones. You divide it by itself. So we divide 1/4 by 1/4 and 3/4 by 1/4. That makes this become a 1, okay? And then we just got to divide 3/4 by 1/4. So we come over here and we go 3/4 divided by 1/4. That means you invert it and multiply. So it's 3/4 times 4 over 1. The 4s, 4 goes into 4 one time, 4 goes into 4 one time. So that leaves us with 3, because 3 times 1 is 3 over 1. So our scale is 1 inch equals 3 miles. Your turn. Find the actual distance represented by 1 inch to write the scale of the map. What are you going to divide both of them by? You know what it is. Pause the video. So we divide both sides by 3/8. That makes this go away and become a 1. We come over here and we go 3/4 divided by 3/8. 3/4 divided by 3/8 is equal to 3/4 times 8 over 3. Okay, so let's cancel some things out. 3 divided by 3 is 1. 3 divided by 3 is 1. 4 divided by 4 is 1. And 8 divided by 4 is 2. So we go 1 times 2 is 2. And 1 times 1 is 1. 2 over 1 is equal to 2. So 1 inch is equal to 2 miles.